The evacuation center is located in Mesa County, Colorado. When choosing a suitable site, it was imperative to select a site outside of the polar reversal and solar flooding areas, while keeping in mind areas that are more vulnerable to solar storms. This led to the selection of Colorado since it was close to a military base and space hub. We analyzed the structure and road suitability in addition to flooding and erosion vulnerability. After combining these criteria, we found the ideal site location in Grand Junction, Colorado, right off the Colorado River.
When designing our evacuation center, we wanted it to be completely self-sufficient and sustainable while meeting the needs of the vulnerable people being brought to the site. After extensive research on creating a self-sufficient site, we proposed a prototype toolkit broken down into the objectives of renewable energy, human infrastructure, essential nutrition, and transportation. Our site includes 6 housing pods with a central medical hub and transportation hub connected by elevated walkways and an autonomous rail line. The medical hub is located in the center of our campus in order to ensure equal access from all areas. Traditionally, people at the socioeconomic bottoms without the financial resources to evacuate or relocate are hit the hardest in emergency events, such as large scale flooding. We included a public transportation system and helicopter system to efficiently serve those who cannot evacuate or relocate on their own. We realized that there will be a lot of trauma occurring before the occupants get to our hub, so we wanted to provide extensive green spaces connecting all the housing pods to the medical hub to help with mental health and PTSD. Phase 1 can be immediately implemented with a transportation hub, 2 housing pods, and 1 green roof, and the medical hub with elevated walkways connecting them all. Phase 1 has a holding capacity of 200,000 people. By phase 2, there will be an additional 2 housing pods and 2 green roofs, leading to a total holding capacity of 400,000 people. The final phase will add the last 2 housing pods and 2 green roofs and an autonomous rail line connecting all housing pods with the transportation hub with a total capacity of 600,000 people.
Our wind turbine farm consists of 40 turbines and will produce about 263 million kilowatt hours annually. With this implementation, we will reduce our site's carbon emissions by 120,000 tons annually. We are also adding 424,000 square feet of solar panels that can produce about 9,636,000 kilowatt hours annually. The use of solar panels will yield a 99% decrease in carbon emission compared to traditional electricity. On-site water harvesting from our green roof has the capacity to yield about 26 million gallons a year and will be used in our vertical farms for food production. Our modular housing pods and circular layout is intended to promote inclusivity and familiarity. Additionally, in the event of a pod being compromised, we can easily move refugees to another pod in the campus using the interwoven walks and corridors. This allows us to isolate and adapt to worst case solar storm scenarios.